Welcome to the weekly shack update from KA4 UPW. The computer center remains in a center partial assembly. Kind of stalled here as we bring around the audio. All my audio equipment has been torn out as we make room for room in this rack to house the audio equipment I talked about last week. And so that pretty much leaves the shack torn apart at this point. I cannot transmit nor receive much. Got one kind of speaker working here. But this isn't today's work, as I'm waiting for the rack stuff to come back from a good friend, Frank, who's doing the machine work. And we'll be showing that assembly later on, possibly later in the week. But what I am bringing you to show you is my Meashastic project. Welcome to the bench. Here we have a solar panel. And if you're not familiar with Meashastic, please look it up on YouTube. Lots and lots of good videos on what Meashastic is, how to take advantage of it, and how to use it. But just to say, this is a APRS-like system. It does not require ham radio license, and it works on 900 megahertz. So, solar panel is going to feed my remote repeater site, a digipeater, buck boost transformer into a UPS power supply. Let's see if I can get that to focus. To the actual mestastic transceiver. This is a repeater. And then finally, an SMA to my 900 megahertz antenna. This is all going to be housed in a waterproof container and then mounted up on a repeater site here in town. And hopefully with that, we'll be able to start meshing up the Daytona area to the Daytona Beach Area, down to Port Orange. There will be a counterpart to this at my home QTH here that will mesh me to this site, and then hopefully, like I said, some of the fellow Meashastic people in the Port Orange and Daytona area, we hope that we'll bring them all into the mesh as well. So that's today's project. I'm just going to set the camera aside, and we'll start making these connections. Alright, well, we're going to start by putting these little crimp connectors on. I'll try to get a close-up. But what these do is, if you've got a screw, if you can't get a spade in there, because this is kind of small, you crimp on this device, and this gives you something solid to bite into, so that you're not just trying to squish some loose wires. We all know how that goes. Nice little device. I got mine. Don't even ask me. Kiwanis. Got it off of Amazon. Saw another amateur using this in a different video. They're really, really nice to use. Just like any crimp on, you just put your wire in, bottom this out in the crimper, complete the crimp, and it has now flattened that out, and you have a good solid connection to be screwed in. So, just going to go ahead and make that connection, and we'll go on to the other side. That was simple enough. Now on to the output, which is going to feed the input to my, this is a 5-volt supply and a backup battery, so that at nighttime the repeater continues to run. So pretty much the same thing here. I'm hoping this is in frame. I'm not very good at recording. And here's the little device, the little crumper. So just a matter of sliding it in. The biter on this bites from 4 directions simultaneously. I don't know if you can see that or not. But it squeezes all sides together. It's a matter of putting it in, complete the crimp, test to make sure you didn't screw it up, and repeat. Again, just not necessary, but I find these just an extra measure of insurance. I'm going to have good solid connection. It's going to be reliable since this will be at a remote site. That's just a matter of hooking the output negative to negative and positive to positive. Later on, we'll adjust this buck boost. I'll probably buck it at 13.2 or 3 volts and boost it to 11 or 12 volts. So I won't let the output of this drop below that, and I won't let the input rise above 13 or so. So, nice and clean, simply done. Now the output of this goes to the input of Meashastic, and I just dropped my antenna. This is just a little SMA to SMA's printed to these little micro printed circuit board connectors, which are a pain in the butt. I will, once this is connected, everything's routed, I will drop a hot glue on this just to assure that the connection doesn't get flaky over time with constant heating and cooling in the summers and the winters. So, but this snaps onto here. So now I'm going to do some testing out. Before I test it out, I need to set the buck boost voltage, and then we'll work on mounting it into the little box. So let me get set up to start testing this out, and I'll restart the video at that point. Alright, you haven't missed much. I got my power supply, a little off camera here, providing me about 15.6 volts. Going to the input of my buck boost transformer, and probably won't be able to read the meter, but this says 15.69 volts. Input, output of the buck boost is 13.0 volts. That's where I set it to with the little trimmer. Just did that off screen. That now goes to my UPS power supply. Input of the UPS power supply is at 13.0 volts. Gives me a battery voltage of 12.9. and an output voltage for the mestastic of 5.296. So this becomes my output. These batteries are already charged. Right now, in the state that it's running in, I'm pulling 0.48 amps. Without this in play, it's 0.15 amps. So I'm losing 0.15 in just the buck boost. Okay, as I plugged it in, there was an inrush current of about 1 amp. That quickly dropped to 0.47. The output of this is a USB-C, which will feed the Meashastic. Right now, the Meashastic antenna has got a 50 ohm dummy load on it, 50 ohm load, so that I don't damage it while we're testing here. I can now power the 5 volts into the Meashastic. I can see its light coming on. Green light flickering. I am now at 0.52 amps as the mestastic does its thing. Small change to the solar panel that I had out here showed earlier. That was actually a 5 volt solar panel, not a 12 volt. So I've replaced that with a 40 volt panel and kept the buck boost at 13. So the reason why such a large panel is, if I have a 12 volt panel and I need 12 volts, then I'm not going to start charging until that panel gets to 12 volts, full sunlight. Whereas with the 40 volt panel, I will start charging as soon as I cross that 12 volt threshold, or maybe a little less with the boost part of this working, that lower voltage up to about 12 volts. And then I will charge all day long, right? Less current, more, but a longer charge time, right? Because I'm going to have anything above 13 volts for charging. I don't have to wait till the panel gets the full 40 volt power to charge. So the nice thing is that I can charge in less, I get more charge hours per day. I get to charge in less than full sunlight. The downside is I'm not going to deliver as much peak current, but as you can see at 0.52 amps, I'm going to have plenty of peak current all the time. So I now have this thing more or less working. The next step is to start stuffing all of this into this box, and including the bulkhead connector for the SMA out for the antenna, which is going to be this. I can do an SMA out for this small antenna and put an external GPS antenna in play, but you guys tell me what you think. I think that the internal GPS is fine. I don't need a super sensitive GPS because this is not going to be mobile, and it's going to be out in the open and clear. And these antennas seem to work just fine. So I think that's the plan currently. So yeah, let's power this thing down. Let's start figuring out how we're going to fit all this into my waterproof container. All right, welcome back. So what I just did off camera was I marked and drilled the holes for the backing plate. I added PC board standoffs to the circuit boards. And now we're just going to mount the circuit boards onto the standoffs. And I want the output on this side and the input on that side. There we go. Simple enough. A couple of screws. And these will get a drop of, that's my APRS noise. And these will get a drop of Loctite when I'm all said and done. Here we go. Starting to take shape. This goes back in like that. And that'll leave me room now for the battery tray, which we'll do next. Same procedure. I'm going to drill a couple holes, put a couple standoffs on, short ones, not these long ones, and I'll be right back when that's done. Alright, so off camera I drilled the holes. Let's go ahead and start the assembly. First thing that goes in will be the bottom plate that's holding the Meashastic transceiver and the buck boost controller. And they get held in with 4 screws that came with the enclosure. Let's see how many times I drop these screws. Try not to drop the F-bomb, but I can't promise. Alright, there's 1. 2. Should have my electric screwdriver. See the wear and tear on the wrist. No carpal tunnel for me. 3. And 4. There you go. I might note that these standoffs here are awful close to a few surface mount components. So if you're going to use these, choose the head size carefully. You don't want to crush any surface mounts. And that looks pretty nice. Now let's just get the backup battery into play. Don't grab the nuts for those, but that's okay. It's going to fit in just like that. Alright, let me fasten it all down and then we'll start connecting things up. I still have the bulkhead connectors to go through for the coax and for the main power supply, or the solar panel in this case. First things first, let's get a couple of nuts back there. I will seal all this with some silicone at the end as well. And I will probably throw a desiccant pack into this whole box just to keep the moisture at bay. Okay, well, I'm going to just cut the video. You don't need to see this. Not much throwing happening here. Alright, I am back. So off camera, I drilled a couple holes. Got one for the SMA and one for the solar. So let's go ahead and install these. Here's my SMA bulkhead connector. It's got a rubber gasket. it'll get a little extra sealing for safety anyhow, but yeah, let's go ahead and install that. Order here, we got a little lock washer. Yeah. Sorry about that noise, that's just my APRS station here. Powers the front end of my scanner. You may hear some Coast Guard or some local repeaters come up on that. That just entertains me a bit while I'm in the shack. Okay, so here's the SMA connector. And of course, that'll get connected to the mestastic. Let's go ahead and tighten this up and then take care of that. So I can't show you this on camera. It's just fiddling with these little connectors like PC board. You know, they were tough when I was 20, but now that I'm 60, I don't see shit. Alrighty. We'll just struggle with that. Pretend like I just said a drop the F-bomb, but I didn't. Okay, there, that snapped in. And like I said, I think that's going to get a drop of hot glue here and here, and also to fix this GPS antenna. But for right now, yeah, I don't know. Do I want that running over that? We'll have to see if there's any noise problems. I think I'd rather keep that pretty far away. Okay. Now it's just a matter of the DC power. It's going to come through on this side. And that should lock that down. There we go. Tuck this wire in first and we'll put it in there. That'll get sealed up when it gets mated to the solar panel with some heat shrink. And the hole is pretty tight, but I will put a little silicone on there as well. Shouldn't take too much, maybe even an O-ring. Okay, let's close this guy up. So there you go. Ready for power. I'm going to go ahead and take care of that off screen. The 900 megahertz antenna. And we should be meshing soon here, huh, I guess? Alright, here's what I got. Back of the solar panel. Power out. Into the device. Waiting for the antenna. So let's move outside. We'll hook this up and get it turned on and started just for see how well I can keep the battery charged. I'm going to run it for a few days before this goes up on the tower, of course. If I need more current, I can parallel up those batteries. But honestly, I think this is going to be enough. Alright, here's what we got. One solar panel, quite large, so I don't want to run out of power. Of course, you do have a hurricane coming here in Florida, so yeah. As soon as I stepped out to start hooking this up, the rain started. This is my 900 megahertz antenna. It's over 6 feet tall. I think it's about a 90 dB gain, maybe 60 dB gain. It's got some RG58 coax. I will pleased that with LMR 400, just long enough to do the job. I powered up the Meashastic. Let's see. This thing to focus. This thing to focus.